let's derive the celebrated Klein-Gordon equation in quantum physics. So the celebrated Klein-Gordon equation is given as the Derivation operator plus the m squared all multiplied by the phi equal to 0. Alright, so this is the expression we want to derive, and this is called the Klein-Gordon equation. To begin with, we need to recall or note that E squared is equal to P squared C squared plus M squared C to the fourth power. This derived from the Einstein energy mass equation. That's how we arrive at this, or the process to arrive at that point. So this is one of the expressions we're going to use. We term this as equation 1. Also, we need to get the energy operator equation. The energy operator equation is given as IH cross. Then we have the del of with respect to t, the partial derivative with respect to t. You can have this as equation 2. We still have what they call P, which is also the momentum operator, and this is minus IH cross, and we have the del. Alright, and this is equation 3. Now I want to plug in equation 2 and 3 into this equation 1. So now we want to plug in this equation 2 and 3 into equation 1, and to do that, for the left hand side we have IH partial derivative with respect to t, and then we're going to square it because of this. This will be was what happens to this. We have P to be this, so we have to square IH cross del squared, then we have C squared plus M squared C to the fourth power. So what is the square of this function? I, we have it squared, and the square of I, or let's keep things simple, we have I squared, that's when you expand this, H cross squared and del squared with respect to the time function. Alright? This will also be, we have this to be I squared, H cross squared, del squared C squared, and then we have plus M squared C to the fourth power. Now the next thing we need to do is to make sure we remember that I squared from complex number is equal to, if I itself is the square root of minus 1, I squared will be that you square this, which will give you minus 1. So that point here becomes minus I H cross d squared over dt squared equal to, similarly we have here to be minus, then we have H cross del squared C squared plus M squared C to the fourth power. I hope that is clear. So the next thing we need to do at this point is to divide both sides of the equation by C squared H cross. And if we are dividing both sides by that, it means that from the left hand side we have C squared H cross, and we have this term also divided by excuse me, C squared H cross, and we have this also to be C squared H cross. So what happened here? You notice that this H cross will cancel with H cross. So what will be left is minus 1 over C squared. We have the del squared over dt squared for the left hand side. On the right hand side, we have that this H cross will cancel H cross, C squared will cancel C squared. So we have minus del squared. And the next thing we're having is this. This C squared will reduce this, so that we have plus M squared C squared all over H cross. So the first thing we need to do is to multiply the both sides of the equation by some sort of function, say phi. Since we have already introduced psi in the system, or we have not, you can use psi or use phi as the case may be. So here we have that minus 1 over C squared partial derivative of this over dt squared multiplied by some sort of function phi equal to, similarly on the left hand side we have minus b squared cos squared or plus m squared c squared over phi squared all multiplied by phi. So what do we need to do next? We need to multiply the whole of the equation by negative sign. If we multiply both sides by minus, it means here becomes 1 over c squared psi squared over t squared, and then that is for the left hand side, and on the right hand side we have here to be del squared plus minus will affect this to be m squared c squared all over h squared crossed, and then this will be 5. But then there's one funny thing I need to do, and that is I want to make sure that because of this fact that h cross is equal to c is equal to 1, that means anywhere I see h cross, I have to replace it with 1. If I see c squared or c, I have to replace it with 1. Keep in mind, c is the speed of light. Alright, so in that case, I'll have 1 over 1 squared, so we have the squared, the t squared left, and this we have on the left hand side. Keep in mind, this is 5. We also have this to be the same way it is, minus, and then we have here to be 1, because 1 squared is 1, and here h cross squared is 1, and then we have just m squared. And keep in mind, this we have 5. Now let's move this to the left hand side of the equation. If we do that, then we're having this squared over the t squared minus, we have this squared, and then we have all of them to have 5 minus, we have m squared 5, this will equal to 0. But keep in mind, for D'Alembert, which is this symbol, is equal to del squared over the t squared minus d squared. Alright, all 5. This is the expression. Keep in mind, the D'Alembert operator have this. And meanwhile, if this crosses, here is already positive sign. So finally, in place of this, we just replace this first part with D'Alembert operator alongside plus this m squared, all of them, because the 5 is common to both sides, 5 equal to 0. And this expression here is what we call the Klein-Gordon expression. I hope you found this video helpful. Please make sure to subscribe to my YouTube channel and follow me more.